I got a question from one of my students. He's confused on how to rate batteries because some of them are rated in amp hour while some of them are rated in kilowatt hour, especially the lithium batteries. Mostly some of them are rated in kilowatt hour. So what we want to do today is just how to calculate the amp hour to kilowatt hour. So now battery measurement. So first of all, knowing that power is equals to I times V. Power in watts is equals to I in amps times V in volts. So what we are looking for is watts because we want it in kilowatt hour. Because most of our lead acid batteries and the wet cell are rated in 200 amp hour, 100 amp hour, 220 amp hour, or 250 amp hour. So let's use this 200 as an example. So you want to change this 200 amp hour to kilowatt hour, like you want to know the value in kilowatt hour. So you take this formula, we go this way. P, which is the power that we are looking for, is equal to 200 amp hour multiplied by voltage. That's actually the nominal voltage of the inverter, like the input, the battery input, the DC input voltage of the inverter. We have 12 volts, we have 24 volts, we have 36 volts, we have 48 volts, and the rest. So using this is the nominal voltage of the inverter. So with this, let's use 48. We are using 48 volts as the nominal voltage of the inverter. 48 volts, which will give us 200 times 48. Let's hold this. I have my calculator here. 200 times 48, giving us 9,600. So this 9,600 is in watts hour. What we're actually looking for is kilowatt hour. Knowing that 1 kilowatt is equals to 1,000 watts. So with this now we say P equal to 9,600 divided by 1,000. That's to have the answer in kilowatt hour. So dividing this thing, we'll have cancelling this 0. There will be a point in front of this place. That's P will give us 9.6 kilowatt hour. So with this answer that we have gotten now, telling you that if you bring 200 amps, 4, that's to give you 48 volts, that the actual kilowatt hour that you will have is 9.6. But due to the fact that most lead acid batteries, the depth of discharge is 50%. Depth of discharge, that most lead acid batteries is 50%. So you going more than 50% is actually affecting the lifespan of the battery. So with this, we divide what our answer, we divide it by 2. That's giving us about 9.6 divided by 2, giving us 4.8 kilowatt hour, which is the correct, like this is the actual thing. So 4 batteries, whether lead acid or wet cell, 4 batteries of 200 amps, 12 volts connected in series to give you 48 volts. The actual power it contains is 4.8 kilowatts. So in case you see lithium batteries of 5 kilowatts, so you actually know that it's just equivalent to 4 batteries of 12 volts, 200 amps. So but calculating with 220 amps, it will be a slight more bigger. So let's just do that really fast. That's calculating with 220 amps. So the mathematics is just very simple. So 220 times 48 giving you 10,560 divided by 1000 giving you 10.56 kilowatts. Then you divide it by 2. So having 5.28 kilowatt hour. So this is actually very simple. Very simple. So this is just the way you do it. So if there is any question, you can drop it on the comment section. We'll attend to it as soon as possible. And thank you so much for your support. Thank you for watching.